Okay, so this video here I'm going to go through the 2017 question B2 on intersecting surfaces. Okay, so the image on the right shows a playground unit incorporating two planar flat surfaces which intersect, as shown to represent the bow of a boat. The unit also includes a triangular seat and two portholes. Figure B2 shows the plan and elevation model of the unit. The horizontal and vertical coordinates of the two intersecting planes ABCD and ABEF are given. Part A. Draw the plan and elevation of the two intersecting planes ABCD and ABEF. Alright, now, so what these means, this coordinate is the x1, the y1, the z1. So the x coordinate is the distance you go from your end vertical plane. Oh, I have another end vertical plane somewhere in this model of another one there. So the x coordinate is how far out you go from the end vertical plane. The y coordinate is how far up from the horizontal plane you go, and the z coordinate is how far out from the vertical plane you go. So you see the z coordinate in plan, the x and y coordinate in elevation, and the x coordinate really and truly in plan as well. So I'm going to get started on this question here. So I'm going to just draw in my YY line, my XY line. Okay, point A is over 205. Okay, so check yourself there, okay, to help you learn. So A is over 205, so point A will be here. Point B is over 235, C is over 195, D is over 185, E is over 145. Okay, F is over 135. So F. And then we're going to do the ones here. So I'm just going to do light lines up here. Okay, just to help me position these points. Okay, A is on the XY line in elevation. B is up 60 from the XY line. So there's B. C is up 20 from the XY line. Okay, D is on the XY line in elevation. So there's point D. E is up 20 from the XY line in elevation. So there's point E. And F is on the XY line, so there's F. Now, so one plane is A, B, C, D. So I'm going to join A to B, and this is it in elevation. A to B, B to C, and C to D. Okay, now the other one is, what is it? A, B, E, F. So A, B, E, F. So there's the elevation of that plane, in those two planes done. Now the next part is to do the plan of the planes. So point A is down 40 mil from the XY line, that's its Z coordinate. So there's point A in plan. B is down 10 from the XY line. Mirren. Okay, B is down 10 from the XY line in plan, so there's point B. C is down 100 from the XY line in plan. So there's point C. D is down 110 from the XY line in plan. E is down 50 from the XY line in plan. And F is down 60. Okay, so there's the points. Now I'm going to connect them together, so I'll just zoom in there. Okay, F to E, E to B, B to A, okay, B to C, C to D, now I've clearly done that thing there wrong. C is down 100 from the XY line and D is down 110, so I just marked in D in the wrong position, so there's D corrected. So C to D and D to A. Okay, I'm going to do D to A lightly and A to F lightly, as some of it will be hidden later. Now, so that's the first part of the question done. The next part of the question says determine the dihedral angle between the two surfaces. So if you want to do that, you have to look down along the line of intersection. Okay, so I'll show it to you in 3D. You need to look down along the line of intersection. So I'll create that there. And you see the two surfaces as edges and the line of intersection as a point. So that's our objective. Now, in order to do that, you need to look along the true length of the line of intersection. The line of intersection between the two surfaces is AB. And students immediately look along it here. And that's not the right step. You need to check. You need to look along its true length. So first of all, you need to check, is it a true length? AB is not a true length in elevation or plan, because if AB is not parallel to the XY line in elevation, it is not a true length in plan. If AB is not parallel to the XY line in plan, it's not a true it's not a true length in elevation. If AB does not appear as a point in plan, it is not a true length in elevation, and vice versa. So, in order to see the true length of a line, you've got to look perpendicular to it. So I'm going to take my set squares here, and I'm going to look perpendicular to line AB. Okay, so all my projection lines here that you see me drawn in make a right angle to the line AB. Okay, now I'll just move the visualizer. There we go. Now, then our x1, y1 line is going to be perpendicular to those projection lines, so aka parallel to line AB. So x1, y1 line. Okay, and I can extend on my projection lines. Now, with that done, we're going to take our heights from elevation. Okay, so it's going to be an auxiliary elevation. Okay, so I'll use my compass here, and I'll take the height of B. Okay, so I take the height of B with my compass. Okay, now you can't see it there. My compass won't make it there as the visualizer is in the way, but I can plot the coordinate. It does say it has an altitude of 60. So I can plot the altitude of 60 out there. So B1, A is on the XY line elevation, so A1 is on the XY line in your auxiliary elevation. C is, you can transfer with your compass if you want, but C is 20 millimeters above from the x1, y1 line, or the xy line elevation, so it's 20 mil above the xy line in your auxiliary elevation. D and F are both on the xy line in elevation, so they're both on the horizontal plane, or the x1, y1 line in your auxiliary elevation. So there's D1 and F1, and then C1 shares, or E1 rather, shares the same height as E1's. So there we go. Now we can join these together. Okay, so that's the surfaces there. Now this is the true length of the line of intersection. So now you look along this. So I'm going to take my set squares here, and I'm going to extend line A1 to B1, and I'm going to project the points there at the same angle as A1 to B1. So that's key, that they're the same angle as A1 to B1. Your x2, y2 line is perpendicular to that angle. It's perpendicular to those projection lines rather. Now, you take the distances from your auxiliary elevation back to your plan. So essentially your x1, y1 line back to plan. So compass there on the x1, y1 line, nib to plan, bring back to B, lift your compass, find B1 in your auxiliary elevation, follow it along, put your compass here, there's B1. You can do the same with A again, and I guarantee you'll get it there. So that's A1, B1, so that's the line of intersection. Now, we're going to do the same with points, these points here, D, C, E and F. So if I put my compass on the x1, y1 line, bring the nib to C, lift my compass, follow C all the way over here, there's C1, and I can do the same with D. So I can follow D along here, compass there, and they mark in together. And then I can do the same here with E and F. So compass here on the x1, y1 line, back to E, lift your compass, follow E over to here, and mark it in. And then you can do the same again with F1, but there's no point, like you'll get it just appearing as a line. Now you couldn't really see that point F1, so I'll just move it there. So I'll do that again. So put your compass on the x1, y1 line, bring it back to F1, lift your compass, find F here, follow it along, mark it in, and then I have a little projection line to bring up, and you do the same with E, as I was saying, and then you join them together here. Okay, so this is the dihedral angle between the two surfaces, because the line of intersection appears as a point and both surfaces appear as edges. Now you should always get into the habit, okay, of measuring the angle. So you should, so whatever angle that is, and write it in there. Okay, so that is 70 degrees. Now, the next part of the question says, I'll zoom out here. Okay, determine the true shape of surface ABC. On the true shape, include a 20mm circle for the porthole, given that the centre is 30 millimeters from line AB and 50 millimeters from point D. Alright, so we want the true shape of surface ABCD. Now, there's many different ways to do this. I'm just going to go with one. Alright, I'm going to get surface ABCD to appear as a line. Alright, that's what I'm going to get surface ABCD to do as. Now, I'm going to look along line AD. And the reason I'm going to look along line AD is because line AD is parallel to the XY line. It's on the XY line elevation, therefore it's the true length of plan. And if you look along the true length of a line, the surface it projects on appears as an edge, or it projects as an edge. So that's why I'm going to do that. So these projection lines here you see are parallel to line AD in plan. So I'm going to project them on, okay, and draw in my x1, y1 line. So I'm doing another auxiliary elevation. Okay, and I'll move the visualizer here now. Okay, so you can take the heights from your elevation using your compass, or you can just plot the distances out with your set squares. You're given the altitudes of them, the y coordinates. Now that's A1 slash D1, A1 slash D1. Alright, B, we're given the altitude of B, which is 60, so I can go up to B here. And because surface ABCD is going to appear as an edge, there's no real need to bother to do C, because if you just intersect, or where that intersects there, that should be 20 mil, okay, which it is, alright, because the surface appears as an edge. So there's C1. Now, the next thing you're going to do is put your compass here on point A1, D1, and you're going to rotate this around there with your compass. And you're going to follow on your x1, y1 line. So this is B now moved to a new position. So surface ABCD is being folded flat onto the horizontal plane. Okay, so we'll be getting a true shape of it. Now, we're also going to move point C1 onto the horizontal plane. So there's C1. Now we've got to project those lines back to plan. So it's at the same angle here now as the projection line. So I'm moving C1 back here and I'm going to move B1 back here. Okay, there's B1 is going to run. It's going to run on a little bit here. Okay, so now the arcs in plan are lines parallel to the x1, y1 line. So I'm going to set up my set square here to be parallel to the x1, y1 line. I'm going to bring it to C, and I'm going to move C out here. So this is the new position of C, and then I need to do it from B as well. Okay, so line that up there with B, and B is going to run right into your elevation. So this now, there's the new position of B. Okay, I'm going to do this in a pen just to make it easier to see. But this is now the true shape of surface A, B, C, D. The true shape of surface A, B, C, D. true shape of it there. That's included. Alright, because that surface has now been folded flat onto the horizontal plane. That's what the x1 and y1 line represents in an auxiliary elevation. So therefore, in plan view, if you move it, you must be looking perpendicular to it. And you can just see the outline bit there. The next part of the question says, alright, on the true shape, include a 20mm circle for the porthole, given that its centre is 30mm from line AB and 50mm from point D. So 30mm from line AB. Okay, so we're going to line up our set square like this, okay, with the new line AB, and we're going to draw a light line along it that you've seen there. We're going to measure 30mm from here. So it's going, and we're going to draw a line parallel to AB. So it's going to be somewhere along there, and it says 50mm from point D. So we'll set our compass to 50mm, and we're going to put our compass on D and swing an arc there until it intersects that line, and its diameter 20, so radius 10. Oh shucks, radius 10 there, where? I have it already set there, and then we can draw in and there. So that's the porthole. Now the next part of the question is the midpoints of line A, B, AD and AF define the coordinates for an oblique plane. So I'll just get the visualizer there going for that. So lines AB, AD and AF define the oblique plane which contains the seat. Draw the elevation and plan of the seat. So we need, first of all, we need to get these 3 points in plan. Alright, it says midpoint. So I'll do just how to do just one of them. You gotta bisect the lines AB, AD and AF. So set my compass to any length, bisect them there. So there's our 3 points. So we can join all those three points there. Okay, and then we're going to have to get them in elevation. So they're 5mm above the XY line in elevation. So I'm going to measure up 5, and you'll see that if you look at the sheet. So I'll measure up 5 there. Light line across. This point gets brought to the XY line. This point gets brought right up to the middle of AB, and this point gets brought up to there, just so happens they're in line. So join to this point here. There, and there's the elevation of it. Now we want to get the plan view of that seat, so we have to drop this down here till it hits there. Drop this one down until it hits the other line. And join together. Okay, now the next part of the question tells us to find the traces of the plane that contains that triangular seat. So what that means is, okay, the plane that contains this surface here, so this one here, where does that plane intersect the vertical and the horizontal plane? Okay, so this one here, where does it intersect the vertical and horizontal plane? Now what we're going to do is we're going to get an edge view of that plane. That's our whole objective, is to get an edge view of it. And if you extend the edge until it hits the x1, y1 line, you get a point view of your HT. And then we can find the VT. Okay, my model is a tiny bit off there, but you can find the VT by using the concept of parallel lines. Okay, I'll do this as quick as possible here as I'm running up on the 30 minutes. Now, I'm going to move that out of the way. I'm going to label this 1, 2, 3. 3, 1, 2. Okay, I'm going to switch colour to a red if it has any ink left. Now, I'm going to look along line 1, 2, so I'm using sliding set squares. 1, 2 is parallel to the XY line in elevation, so it'll be a true length in plan. Okay, and it's out of ink. And I'm doing the same. Doing the same with point 3 here. Okay, and then I'm going to, my x1, y1 line will be perpendicular to those lines. So I get my height from elevation. So I'll take the height of 3, lift my compass there, put it there. This is point 3. 1 and 2 are 5 mil above the x1, y1 line, because that's their coordinate in elevation. This is an edge view of surface 1, 2, 3. So that's 1/2, 3. Now, if I extend this down, where it intersects the x1, y1 line is a point view of the HT. Now, there's other ways to do it, but you know, I find second level students, there's only a set number of ways they can remember it, so it's better off just to master one. Now bring your HT back down here, and this is your HT. So HT. Now, in order to get the VT, draw a line parallel to the HT through any of the numbers. Doesn't matter whether it's 1, 2 or 3. Okay, so I'll pick 3 here, and you'll notice you already have it done. Where it hits the XY line, okay, bring it straight back up and then across from point 3 in elevation, and where they intersect there, join that back to T, and then you have your VT. Alright, so I'll zoom out here as best as I can, and you'll see what the question should look like. There you go. Cheers, thank you, bye bye.